So we've already talked about adding and subtracting polynomials. We did that in a different worksheet video. But in this case, we're going to bring back adding and subtracting polynomials, but now we're going to have multiple variables. The process is exactly the same. You just have to be a little more cautious with what is and is not going to be like terms. So just a little gentle reminder, when you're dealing with like terms have to have matching variable factors, okay? So like terms would be things like x squared y and yx squared. Though these variable factors are not in the same order, we have the same variables, the same exponents. So these are technically matching variable factors, okay? Because of the commutative property of multiplication, we can take the x and multiply it by the y. We can take the y and multiply it by the x. We're going to get the same thing. What would not be like terms would be something like x squared y and xy squared. Even though we're dealing with x's and we're dealing with y's and we're dealing with exponents of 1 and 2, the exponents are on the wrong variables. So these are not considered like terms over here. So you do have to be a little bit more cautious with what would constitute like terms versus not like terms. But other than that, the process for adding and subtracting polynomials is exactly the same. Okay? So regardless of the number of variables, distribute to remove parentheses and then combine like terms. Remember, when we're multiplying or when we're adding and subtracting polynomials, we're going to be given each polynomial in a set of parentheses. And what we have to do is distribute either a positive or a negative one. So if there's nothing in front of the parentheses at all, it's distributing a positive one. If there's a plus in front of the parentheses, it's distributing a positive one. If there's a negative in front of the parentheses or a minus in front of the parentheses, then you're distributing a negative one. And that's where you need to use a bit more caution. So if there's a plus or nothing at all in front of the parentheses, you just kind of drop the parentheses. If there's a negative or a minus in front of the parentheses, then you have to do a little more work. You have to watch your signs there. But otherwise, it's just getting rid of parentheses and then combining like terms. Okay, so let's look at example 3. It says find each sum or difference. Part A, we have a sum. So again, we technically are distributing to remove parentheses. We're distributing ones and negative ones. So for part A, I'm distributing positive ones. So 1 times 4x squared y plus 1 times 8xy plus 1 times 11 is just 4x squared y plus 8xy plus 11. I now need to distribute a positive 1 through the second polynomial. So 1 times negative 2x squared y is just minus 2x squared y. 1 times 5xy is 5xy. And 1 times 2 is just plus 2. Okay, so nothing really earth-shattering there. Now, we do need to make note of like terms. So like terms have to have matching variable parts. The variable parts have to be exactly the same. Same variables, same exponents. So if I look here, I, for my first term, have x squared y. Do I have another term with an x squared y? I do. So I have two terms that contain an x squared and a y. Now I need to look to see about my next type of variable terms or variable factors. So the next term I have is going to have just x to the first, y to the first. Do I have another xy term? Yes, I do. I have a 5xy. So those are considered like terms. And then finally, we have constants. Constants are always considered like terms with each other. So now you can see in red, purple, and green are different pairs of like terms that need to be combined. I want at most one x squared y term. I want at most one xy term, and I want at most one constant term. So let's look at the ones underlined in red. So we've got x squared y. Well, I have 4x squared y minus 2x squared y. 4 minus 2 is 2, so I just get 2x squared y. Next, we move to the purple underlined terms, which have an xy factor. So 8xy plus 5xy is just 8 plus 5, or 13xy. And then 11 plus 2 is just 13. So there you have it. You want to know that you have at most one of each type of variable term, okay? Next up for part B, same exact process. We're going to eliminate our parentheses by distributing 1 and then negative 1. Distributing a 1 is easy. Distributing a negative 1, you just have to watch your signs. So for the first polynomial, I have 1 times x to the fourth, 1 times negative 7xy, 1 times negative 5y to the third. So I basically just rewrite my first polynomial. My second polynomial, though, is being subtracted. And in order to subtract all of those terms, we distribute a negative 1. So negative 1 times 6x to the fourth is minus 6x to the fourth. Negative 1 times negative 3xy becomes positive or plus 3xy. And negative 1 times 4y to the third becomes minus 4y to the third. So let's look and see what types of terms we have. So, whoops. There we go. So x to the fourth, I have two different x to the fourth terms. So we'll do those first. Let me plug my computer in before it dies. Hold tight. All right, next up, let's see. We have x to the, so we have xy and then we have y to the third. So let's look at our xy terms. So I have xy here with negative 7xy, and then I have 3xy. So we've got two xy terms. It looks like next up we have y to the third and then y to the third. So I think that's it. We have three pairs of like terms. So let's combine. Let's go ahead and start with x to the fourth. So 1x to the fourth minus 6x to the fourth is just 1 minus 6, which is negative 5, x to the fourth. Okay, next up, let's do our xy terms. So negative 7xy plus 3xy. Well, that's negative 7 plus 3, which is negative 4xy. And then finally, we've got our y to the third terms. So negative 5y to the third minus 4y to the third. Well, negative 5 minus 4 is negative 9. And then we keep y to the third. So there you have it. It's the exact same process as just adding and subtracting polynomials with a single variable. But here, we just have to be a bit more cautious with what we have for like terms. And that's it. Let's see. Excuse me.